one of the cases earlier where they were dehydrated and they had a high sodium count.
Yeah. So here we don't have a high sodium count.
Yeah. Okay. Yeah.
Okay. So, but yeah, that's a good point. If the sodium were high, then you might well be thinking possibly a dehydration. Could be other things. It could actually be an overhydration. Remember, sodium tends to change probably more often than not because of a water problem. So you could have too much water, too little water, and well, actually, yeah. So if you have too little water, it tends to be high.
Okay,
yeah.
so the normal sodium tells us that it's not a dehydration.
Well, it tells us that that's not what we should primarily be looking for, yeah.
Can a person who is dehydrated have a normal concentration of sodium because the sodium and the water, like, they are lost in proportion or something?
Yeah. So the question is, and it's similar to a question that we had earlier, can a person who's severely dehydrated have a normal sodium? And the answer is yes. Yes, if the conditions are just right and you lose sodium pari passu with water, yes, it can. And I think we mentioned that at least acutely, and in fairly mild terms, diarrhea is one such thing that might present with an isotonic loss. Okay. Okay, good. Let's do some Darrow-Yannitt diagrams. What we're going to try to do is we are going to try to figure out when we have a fluid insult, whether it be having too much fluid, too much sodium, too little fluid, too little sodium, we want to find out how the fluid distributes between the compartments. The compartments that we talked about this morning. So, you can actually get to the point where you can figure out exactly where fluids go without the use of a diagram. But I think it's useful to use a diagram, and two, step questions may use these diagrams anyway, so we might as well go through them. So this is a Darrow-Yannitt diagram. And kind of what it is, I'm going to label this ECF, ICF. Is that the way around it is on these diagrams? ECF on the right? Yeah. Okay. What this is it's basically a couple of graphs put together. So this is volume. And this is volume. And this is osmolarity. And remember, I'm a physiologist, so I'm going to make everything easy, call that 300. So in the ECF, we'll have a volume, let's just say it's 14, which is not a bad value, 14. And 300, so basically an osmolarity of 300, a volume of 14, put a line there, and we're just basically filling in the box, yes? And same over here. let's say we've got a volume of 28, which is here, and the osmolarity should always balance, such that inside and outside of cells are always in osmotic balance. Okay, so this line is always straight across here. So this is also 300. This is 28. It's kind of like, so basically it's just kind of like plotting two graphs back to front. So how can we use that? So what we're going to do is we're going to split this up. We're going to have a fluid forcing. We're going to have an equilibration phase. And then hopefully a correction. So the idea is that no matter what our forcing is, the water is going, only the water moves. So let me just put this. Let me do an example, and I don't know which is the first one I had planned. Oh yeah, let's do an easy one. Okay. So this will be the bottom left on your diagram. And this is, say, an infusion of isotonic saline. So isotonic saline I'm going to use some colors here. Let's add a liter of isotonic saline. You can only add things to the extracellular fluid in the first instance, yes? You can't plug it into cells immediately. So 1 liter of isotonic saline, in the first instance, if nothing happened, this would come out to 15, yes? The volume. Got it? What happens to the osmolarity? Nothing at all. And so you'd actually come to a point here where it's still 300, but it's 15. And so if nothing happened, that would be the new situation. Now we've got an equilibration phase. Except that, which way should water move across the membrane? Nowhere, because it's in perfect balance already. So this is not only the initial insult, but it'll also be the final equilibrium position, like so. Okay? So, gosh. So if we're smart clinicians, I've just shown you a way of selectively bolstering the extracellular fluid. And you're kind of looking at me, yeah, okay. This can be clinically useful. Okay? So isotonic saline will tend to bolster selectively the extracellular fluid. And we'll talk more about that. So next, let's go to the one on the bottom right. It says SIADH. Let's just call it drinking water. Because SIADH, which is the syndrome of inappropriate ADH secretion, is kind of like drinking free water. So drink water. Let's drink a liter of water. 1 liter of water. And we can do this in stages. So if we drink a litre of water, ooh, this will go out. Initially, it would want to go to 15, right? 15. So what happens to the osmolarity?
Down.
It's got to go down. And so I'm going to do an intermediate position here.